Good morning to all of you. This is Mova Prasad signing into DCB Suryapeta online live streaming SST online classes. Already we have completed 4 classes in our probability topic. Now we are in the 5th day. Almost all concepts which are covered by our Purushottam sir by concept wise, and every it depends upon the terminology wise also. Already he has completed exercise questions and a little bit of questions which are left in the last exercise. And one more thing, the types of questions which may be asked in your examinations, and what is the how many marks may be allotted to this topic in your annual examination is also be going to be discussed with you. So this is one of the most important topic which consisting of only one formula and getting more marks in your annual examinations. Only one formula wherever you go and whenever you go, just you write the fundamental formula, you can get at least half mark for that one. That is only the one topic in the entire 10th class, so which is discussed by our Purushottam sir. It's a very pleasure for us. So Purushottam sir, please go through.
Good morning to all of you. Yesterday we discussed some problems on playing cards and on dice and spinner. Today we are going to remaining problems with fully discussion. See children, now today is the last day class, so listen carefully children. Once again I will repeat the basic and classical formula of the probability is, okay children, that is correct, is probability of event is equal number of favorable outcomes divided with number of possible outcomes. Now we will go to the third problem in exercise 13.2 children. So listen carefully here. A kidney bank contains 150 pice coins, 50 1 rupee coins, 20 2 rupee coins, and 10 5 rupee coins. Listen carefully. Yesterday I repeat it. Okay. If it is equally likely that one of the coin will fall out when the bank is turned upside down, what is the probability that the coin? A kidney bank. A kidney bank is there. In the kidney bank, 150 pice coins. How many 50 pice coins? 100. How many 1 rupee coins? 50. How many 2 rupees coins? 20. How many 10 rupee coins? 10. So here he asked the probability, number 1, will not be a 5 rupee coin. Will not be a 5 rupee coin. Second one, will be 1 rupee coin. Will be 1 rupee coin. Not 5 rupee coin. Second one will be 1 rupee coin. See children here. Now will not be a 5 rupee coin. So here the number of 50 pice coin 100, number of 1 rupee coin 50, number of 2 rupee coin 20, number of 5 rupee coins 10. Here total number of coins, children. Here we take total number of coins. Why children? Because the number of possible outcomes. Because here we want number of possible outcomes. That's why we take the total number of coins. So number of 50 pice coins 100, 1 rupee coin 50, 2 rupee coins 20, 5 rupees coins 10. So we add all the coins 100 plus 50, 150 plus 170 plus 10, 180. So we may take it as the number of possible outcomes. Number of possible outcomes. Now, so that the total number of outcomes for a coin to fall down is how many children? Yes, 180. Total how many? 180. Now, not be a 5 rupees coin. Not be a 5 rupee coin. So here, number of outcomes favorable to 5 rupee coins. Here, 5 rupees coin how many? 10. But we want here, number of outcomes favorable to not be a 5 rupee coin. Here we want not be a 5 rupee coin. Here favorable 5 rupee coin favorable 10, but we want not be a 5 rupees coin. So we subtract total coins minus a 5 rupees coin. So we get 180 minus 10. Children, see children here. 180 minus 10, 170. Here 170 are the 170 coins are not be a 5 rupees coins. So we may take it as favorable outcomes. We may take it as favorable outcomes. So here, once again, we will repeat the classical formula probability. Yes, children, what is the probability? Number of favorable outcomes by total number of outcomes. Here, number of favorable outcomes to not be a 5 rupee coin and the total number of outcomes. So, next one here, what? Here already number of favorable outcomes are there, 170. Total number of positive outcomes are there, 180. So 170 by 180. Here 10 17 10 18 0 0 cancel. 17 by 80 is the probability of not be a 5 rupee coin. Have you understood, children? This is 17 by 18. 17 by 18 is the probability of what? Not be a 5 rupee coin. Okay, children? Write down, note down this one, children. Now let's look at into the next one, children. Here, second, next one will be 5 rupee, will be 1 rupee coin. Will be 1 rupee coin. Now, here, the number of favorable outcomes to be 1 rupee coin. Already how many 1 rupee coins are there, children? Yes, 50. That's why 50 is the number of favorable outcomes. Here 50 will be number of favorable outcomes. Already we know that total number of possible outcomes already we know that how much? 180. So total number of possible outcomes 180. Here the probability formula once again. The probability formula once again we may recall probability is equal to number of favorable outcomes divided with the total number of outcomes. Number of favorable outcomes divided with the total number of outcomes. So children, we may substitute the values. So we get a 50 by 180. 50. Here we take 50. Why we take here 50? 50 is the favorable outcomes to 1 rupee coin. Favorable outcomes to 1 rupee coin. And 180. We may take here 180. Why? It should be total number of possible outcomes, total coins, favorable coins, total coins. We may get 5, 10 5s are 10 18s are 0 0 cancel. We may get 5 divided 5 by 18. The probability is 5 by 18. So here like this. So we may create so many problems. Will be a 5 rupee coin, will be a 50 paisa coin. There are so many problems we create using this one. Okay, children, please try it. Okay. Next one we will discuss. See, children, here another problem is there. Fifth one is there. Listen carefully. See, children, here a game of chance consists of spinning an arrow which comes to rest pointing at one of the numbers 1, 2, 3, 4, 5, 6, 7, 8. See figure. This is the spinner. Do you know about it? This is the spinner. Okay, here in our surroundings. Okay, we may see it often, or we we create or we make a spinner also. Here, this is one of the game. Okay, generally we and these are equally likely outcomes. These are equally like this spinner is there. Numbers, how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8 numbers are there on that. 8 numbers are there. Here is the arrow is there. It is the arrow. When we spin this one, it stops at a number. It stops at a number. So that's why here. And these are equally likely outcomes. So what is the probability that it will be pointed? The arrow is stopped at the number. Here 8. The arrow stopped at the 8. The arrow stopped on an odd number. Okay? Stopped on rest pointing. It's a pointing. It's a pointing. 8. And an odd number. A number greater than 2. So a number less than 9. So 4 problems are here. Using this figure, we may solve these 4 ones. These 4 ones. So here, first of all, we will try to the pointing on X. The arrow is pointing on X. Here, number of total outcomes. First of all, this is the very important one. In every problem, we may find total possible outcomes. In the same way, here we also find here the total number of outcomes. Here, number of total outcomes are how many children? Yes, 8. Those are 1, 2, 3, 4, 5, 6, 7, 8. Because 8 numbers are there on the spinner. If 3 children and favorable outcomes, the point is pointing at 8. The point is pointing at 8. How many? When we spin only one time. When we spin only one time. So the favorable outcomes are how many children? Only 1. That's why here already possible outcomes are there, favorable outcomes are there. Simply, once again, the formula is there. What is the probability? Here, number of favorable outcomes divided with the total number of outcomes. That's why here, number of favorable outcomes to 8. Here, number of favorable outcomes to 8. Total number of outcomes are there. Simply, we substitute the values, we get the probability of pointing on 8. The probability of pointing on 8, P of 8, we may take it as P of 8 is equal to 1. Here, favorable outcomes are 1. Total number of outcomes are 8. So 1 by 8. This is the simple answer. 1 by 8 is the answer. The probability of pointing on 8, we may find out here 8. So what is the probability? 1 by 8. Simple. This is the 1 by 8 is the final answer. Second one, see children here, that it would be an odd number. The pointer stops at an odd number. Odd numbers. So here, I already discussed in yesterday class. What is odd number? When a number is divided with 2, we may get remainder 1. Those numbers are odd numbers. Odd number, even numbers. Composite number, prime numbers. Those are separate. These are separate. Prime numbers, composite numbers, and here even number, odd numbers. Even number, odd numbers. That's why. Number of odd numbers on the spinning wheel. Already we know what total possible outcomes are there. 1, 2, 3, 4, 5, 6, 7, 8. Total possible outcomes of 8. Among those, here we want here an odd numbers. Odd numbers. Odd numbers are how many? 8 children. 1, 3, 5, 7. 2, 4, 6, 8 are even numbers. We know about it very well. Okay, so that's why here we get odd number 1, 3, 5, 7. How many odd numbers are there? 4. How many odd numbers are there? 4. That's why we may take it as favorable outcomes. We may take it as a favorable outcomes. Once again, the probability is equal to number of favorable outcomes to an odd number by total number of outcomes. Total number of outcomes. So same, the process is same. We may substitute the probability of an odd. The probability of an odd is equal to 4 by 8. 4 is favorable, 8 is total. So 4 by 8, 4 1 is 4 2 is 1 by 2 is the probability of an odd number. So we may create another one, an even number. Try this. We may create another one, an even number. It's also very easy. Okay? Using this one, we may create a prime number also. We use prime number, composite number. Find the probability of prime number. Find the probability of composite number. Okay, we may create so many problems using this one. Using this one. Here, the probability is what here? 1 by 2. 1 by 2. 1 by 250%. Okay, now third one. See children here, third one. A number greater than 2. A number greater than 2. So here, already once again, but now we find the total outcomes are there. Total outcomes are, number of total outcomes are there. How many? 8. 1, 2, 3, 4, 5, 6, 7, 8. So among these, we find out greater than 2. Greater than 2 are favorable. Here we find out greater than 2 are favorable. What are they? So here, greater than 2, see children here, a number greater than 2 are, a number greater than 2 are, see children, 3 is greater than 2, 4 also, 5 also, 6 also, 7 also, 8. These numbers are greater than 2. Here we may take above 2. Above 2. That's right. How many? 1, 2, 3, 4, 5, 6. Yes. Here already we find favorable outcomes. Number of favorable outcomes. Number of favorable. How many children? Yes, 6. So the favorable outcomes are how many children? 6. That's why already total number of outcomes are there. Favorable outcomes are there. Yes, you proceed. Children, watch here once again. Here is a formula for you. Probability, number of favorable outcomes by total number of outcomes. So simply we substitute the values. We may get what here? P of E. Here P of E means here an event. P of E is equal to 6 by 8. Okay, children. 6 means what here? 6 means favorable. 8 here total. That's why we may take 6 by 8. Favorable by possible, total possible, 6 by 8. 2 3 is 6 by 2 4 is 8. So 3 by 4. 3 by 4 is the probability of a number greater than 2. The probability of a number greater than 2 is 3 by 4. What here? 3 by 4. 75%. 75%. Okay. Now, next one is the children. So here fourth one. Fourth one, children. A number less than 9. A number less than 9. We find the probability of a number less than 9. So children, what are the total outcomes? Here, the total outcomes are there. Here, a number less than 9 are totally the total positive outcomes are less than 9 only. Less than 9. So these all are these number 1, 2, 3, 4, 5, 6, 7, 8, 8. These 8 numbers are less than 9. 0. Okay. That's why we may take favorable outcomes are how many children? Favorable outcomes, how many? Total means 8. That's why. Okay. Favorable outcomes. All are less than 9. That's why we may take all favorable outcomes. Total number of possible outcomes are there. Possible outcomes. Possible outcomes are and favorable outcomes are same. That's why we may call it as sure, so that it should be certain. It should be certain or sure. See children here, once again, the probability formula, number of favorable outcomes by total number of outcomes, total number of outcomes. Oh here, see children, P of E is equal, P of E is equal to 8 by 8. 8 by 8. Why? Because all numbers 8. Total number of our outcomes 8. Okay. And outcomes, total number of our outcomes 8. That's why we may take 8 by 8. Is 8 by 8 is equal 1. Less than 9. We take less than 9. Less than 9. Total possible 8. Favorable 8. That's why it is tell me children, this type of event is called, when the probability is 1, then the probability is 1, such type of event is called what children? Yes. What children? This is a sure event or certain event. Okay, 8 by 8. A sure event or certain event. If the probability is 1, such event is called sure event. If probability is 0, such event is called impossible event. Impossible event. We look into next problem, children. See children here. Write down first of all this one. Seventh problem. 5 cards. How many cards here? 5 cards. The 10. Jack, Queen, King, and Ace of diamonds. These 5 cards are diamonds. In a deck of cards, 52 cards are there. 4 sets are there. Okay. 4 color, 2 colors. Each color contains 26 cards. We know it very well. So here we may take only 5 cards. We may take only 5 cards. Those are diamonds. Those are diamonds. That's why. What are they? 10. 10 cards. Diamond 10 card, diamond jack card, and diamond Q, diamond K, and diamond A. These 5 cards are there. How many cards are there? 5 cards. Are well shuffled with their face downwards. Face downwards. Okay. We can't see what it was. One card is taken. One card is then picked up at random. One card is then picked up and random. One card is picked up. We find the probability. What is the probability that the card is the queen? See children here. What is the probability that the card will be a queen? Will be a queen. Second one. If the queen is selected, and put aside, for example, queen is selected, put aside without replacement, what is the probability that the second card is selected is an ace, B, a queen? See children, here in second question, 2 sub are there, 2 sub questions are there. First of all, we find the first one. So what is the probability that card is a queen? So here children, what is the probability? Solution here. So here, total number of cards. How many? 5. Why? Because only we may take 5 cards only. That's why total outcomes are how many? 5. And the number of total outcomes are 5. So now here favorable. We find out here favorable. Number of outcomes favorable to queen. How many queens are there? Only one queen. That's why we may take the favorable outcomes are only one. Only one. Total 5. Simple. So the probability formula is there. Once again, probability is equal to number of favorable outcomes by total number of possible outcomes. Already we know very well. So that's why simply P of queen, probability of Q means here queen, P of Q is equal to 1 by 5. 1 by 5. The probability is what here? 1 by 5. Second, okay? Second one is what? In second one, another two problems are there here. When the queen is selected and put it aside, we remove it. Already among the 5 cards, a queen is there. Queen, put it aside. Remaining cards are how many children? Only 4. Remaining cards are how many? 4. Then the total outcomes are how many? Yes, 5. In previous, total number of 5. Here in this problem, total number of 4. That's why. That's why we take it. 4 is the total number of outcomes. Now, second one, A. An ace, that it should be an ace. Tell me, children. Here total outcomes are there. Total outcomes are there. We may find favorable outcomes. We may find favorable outcomes to an ace. To an ace. How many children? Yes, you are correct. What? How many? Number of favorable outcomes to an ace is only 1. Only 1. That is a diamond ace. That is a diamond ace. That's right. Now, the probability formula. The probability formula. Number of favorable outcomes divided with the total number of outcomes. Here already 1 is there, favorable is there, total is there. That's why the probability is what, children? Yes, you are right. The probability an ace A is equal to simply 1 by 4. This is the answer. Simply 1 by 4. This is the analysis. This is the analysis. First of all, we read much and much, and what we want here. Here only favorable outcomes and total outcomes. That's right. Okay. Right here, the probability of an ace. The probability of an ace is equal to what? 1 by 4 is the probability. 1 is the favorable, 4 is the total outcomes. That's why 1 by 4. Now B. Second one, B. Be a queen. That it should be a queen. Already here, children, see children here, number of favorable outcomes to be a queen. Already we selected a queen and put it aside. We remove it. We remove it. Favorable. How many children? No favorable. There is no outcome to favorable to queen. When we may pick up a queen, there are no queens among the 4 cards. Among the 4 cards. That's why we take number of favorable outcomes here 0. 0 because already queen is selected and put it aside. Put it aside. So children, now if the probability, already we know this. You see children, favorables are 0. Tell me children, what we called? Yes, that is impossible. That is impossible. So probability, favorable outcomes by total number of outcomes, favorable outcomes 0. Number of total outcomes are how many children? 4. That's why P of Q here in this previous, for the first one P of Q 1 by 5. Here P of Q 0. Why? Because the queen is selected and put it aside. We remove the queen. We remove the queen. That's why there is no queen. That's why the favorable 0. That's the favorable 0. So P of queen is equal to 0 by 4. 0 by 4 means 0. So if the probability is 0, what we call probability 0? What do we call children? Impossible event. Impossible event. Probability 1 sure event. Okay, like that. So here 0 by 4 is 0, impossible event. The, the probability of failure here is 0, that is impossible event. Now we move into next one, children. See children. See children, eighth one. Listen carefully, children here. 12 defective pens. Defective means spoiled, not much, less, are accidentally mixed with 132 good ones. It is not possible to just look at a pen and tell whether or not it is defective, not is it is defective. So it's just a smaller defective is there. A small defect is spoiled. So we can't identify just a small defect is there. One pen is taken out at random. If one pen is taken at random from this lot, determine the probability that the pen taken out is a good one. Here, see children here, another example is there, another problem is there. 12 defective pens. A smaller defect are accidentally mixed. These 12 mixed with 132 good ones. These 12 mixed with 132 good ones. So it is not a possible to look just like a pen is because a very smaller defect. That's why one pen is taken out random. One pen is taken out random. Determine the probability that there is good one. Determine the probability there is good one. So we may find here, children, the probability that the pen taken out is good one. We find the probability of a good one. So here we find favorable and total. Simple. Think, children. Favorable how many and possible how many? Yes, children, favorable. Here number of good pens is how many here, children? 132. And number of defective pens 12 mixed with each other. Total how many? 132 plus 12. How many, children? Yes, you are right. So total number of pens outcomes 132 plus 12. How many? 144. How many? 144. Why? Because we mixed it. So total how many pens are there? 144. So we may take it as a total outcomes. 144 is a total outcome. Now we find a good one. If we pick up, if we take a good one. Now favorable outcomes. How many favorable outcomes are there? Number of favorable outcomes in taking a good one, good pen is how many? 132. Total 144. The favorable, good one favorable 132. Defective favorable 12. Now we find good one only. Now we find a good one. That's why the favorable are how many, children? 132. Favorable 132. So favorable is there, total is there. Simply we may substitute it in our formula. What is that? The probability is equal to number of favorable outcomes to good ones by total number of possible outcomes. Total number of outcomes. Total number of outcomes. We may substitute what here? Probability good pen is equal to simple 132 by 144. 132 by 144. 132 here, 132 is favorable, 144 here, total possible. That's why we simplify it. We simplify with 12 table. 12 table. We may get here 12 1 ja 12, 12 1 ja 12, 11, and 12 11 ja 132, and 12 12 144. So that's why the probability of good pen, good one is 11 by 12. Using this, we may find the probability of defective pen. Okay, is another question. We create another question. Using this one, we may find probability of defective pen. Probability of defective pen. Okay, try that one. Now, we goes to next one, children. So children, here another very important and important problem is there. Suppose here, suppose you drop a die. You know very well about the die. This is one of the cube. Okay, six faces. Okay, equal faces. And suppose you drop a die at random on the rectangular region shown in the figure. Oh, this is a rectangular region. What is a rectangle? Length and breadth. This is a rectangle, not a square. This is a rectangle. Length and breadth. Length and breadth. What is the probability that it will land inside the circle with the diameter 1 meter? So if the circle is there, this is the rectangle. In the rectangle, a circle is there, subscribed in a circle. Circle is subscribed in a rectangle. Okay, that's why here. So the circle is inside the rectangle. The diameter of a rectangle is only 1 meter. 1 meter. So now we find what is the probability that will land. If we drop the die, that will start in the circle region only. What is the probability of that? Okay. If we may drop the die on this figure, if we may roll die, it must be inside circle. We find that probability only. We find that probability. Not if you roll the die, it is stop here, it stop here, it stop here. But we find the probability of inside the circle. What is the probability that it will be landed inside the circle with diameter 1 meter? Okay, children. Now, see, children, here from the figure, already we saw the figure, rectangular figure. That is rectangular figure. Rectangle. So the length of the rectangle is what here? 3 meters already given. The length of the given rectangle is 3 meters. And it breadth also. Length, breadth 2 meters. Length 3 meters, breadth 2 meters. And the diameter given of the circle. Diameter of the circle is 1. And what is the radius? What is the radius circle? D by 2. R is equal to D by 2. 1 by 2. So diameter of circle is 1 meter. Here radius is used. Diameter also is used. Diameter is 1 meter. Now, see, children, here area of the rectangle. The total area of the why we use the area of the rectangle? Because the total rectangle area is the total region. That is a possible region. That's why we may take a area. Here, area of the rectangle is equal to 3 into 2 into 6 square meter. 6 square area of the rectangle. And area of the square, already we discussed the formulas. Perimeter, the rectangle, perimeter of the square, area of the circle, circumference circle. Okay, here we may take that a rectangle figure. That's why we may area of the rectangle length into breadth. Okay, children, area of the rectangle length into breadth. L into D, LB square meter. So 6 square meter. It was a 6 square meter. Now, children, here this may we take total area of the region for landing. If we roll the die, this is the total favorable. Total possible. We may take it as total possible. Now we find favorable. See, children, here. Now, area of the circle. When we roll the die, it stop on the area of the circle. That is the favor. It land inside the circle. It lands inside the circle. That's why we may take area of the circle. We may take area of the circle. See children, recall the area of the circle. What is the area of the circle? 2 pi r. Sorry, 2 pi r is not here. 2 pi r. Pi r square. For children here, area of the circle is pi r square. Not here. This is correct. This is the 2 pi r is the circumference of the circle. Here area of the circle is pi r square. Here circle is pi r. Here simply we may take d. Pi d square. Pi d square. Remove this. Pi d square by 4. Area of the circle is pi d square by 4. Equal red mark is there. Pi d square by pi r square. Area of the circle is pi r square. That's why. See, we may substitute the value. We may substitute the value. Is what here, children? Pi means 22 by 7. Pi means 22 by 7. So here d square and 1 into 1 by 4. 1 into 1 by 4. So here 22 by 7 4 ja 20. It is a favorable region. That is the favorable region. Now the probability of the die to land on circle. The probability of the die to land on circle. Favorable region by total region. Okay, children? Favorable region by total region. Okay? Now, see children here. Favorable already just we find 22 by 28. The probability. Now, the probability is favorable. Area of the circle 22 by 8. Total area of the land is 6 square meter. That's the 22 by 8 by 6. We simplify it. Now, like this. Here 22 by 28 by 6. 22 by 28 by 6. It 28. It may take here in as denominator 22 by 28 into 6. 22 by 28 into 6. So here we simplify. We simplify as a short form here now. Here 2 3 ja 2 11 ja 11 by 28 into 3. So 11 by 28 into 3 84 square. This is the probability of 11 by 84. 11 by 84 is the probability of a die to land on a circle. A die to land on a circle. So this is the way to solve the problem. Okay, if this is a region problem. This is a region problem. This is a place area problem. So we may take like this. Okay, we may do like this. Area of the favorable circle by total area. So that's why here 11 by 84 is the probability. 11 by 84. Another one is the children. A game consists of tossing 1 rupee coin 3 times and noting its outcome each time. Deekshita wins if all the tosses give the same results. That is 3 heads or 3 tails, and losses otherwise. Calculate the probability that she will lose the game. Another one, 41 children, 3 children here. A game consists of tossing 1 rupee coin 3 times. 1 rupee coin, how many times? 3 times. Now, here, Deekshita wins if all the tosses give the same results. That is 3 heads. If 3 heads or 3 tails, then she wins. Otherwise, she lost the game. So here, calculate the probability she will lose the game. This type of questions will ask her. Okay, like that. Here, calculate the probability that she will lose the game. We find out the loss of the game. Okay, now see children here. So if a coin is tossed for n times, total number of outcomes. This is a simple formula is there 2 power n. Or here 2 power n. So if a coin tossed one time, 2 power 1 and 2 times. The possible outcomes are there 2. If a coin is tossed 2 times, 2 power 2, 2 into 2, 4. 4 possible outcomes. If a coin is tossed 3 times, 2 power 3, 2 into 2, 8. So here, how many? Here we may take 3 times. The possible outcomes are 8. The possible outcomes are 8. Okay, children. Next, see children here. They are a coin tossed with 3 times. Coin tossed 3 times. The 8 possible outcomes are there. 8 possible outcomes are there. They are TTT, TTH, EHT, EHH, HTT, HTH, HST, HHH. So these are 1, 2, 3, 4, 5, 6, 7, 8. How many total outcomes are there when you pass it 3 times? Yes, 8. Total possible 8 outcomes are there. Now, so from above, number of favorable outcomes. Now favorable. Now we see favorable. Here, when all 3 TTT, HHS, when these two comes, she wins. But we want here, she lost the game. The probability of she lost the game. That's why you may take these 1, 2, 3, 4, 5, 6. So 6 favorable. If TTT, HHH, she wins the race. But we want she lost the game of probability. That's why we may take the favorable outcomes are 6. Have you understood, children? We remove the TTT, HHS. That's why the favorable are 6. Why? Because the probability here we find the probability of she lost the game. She lost the game. That's why we may take favorable 6. Now, okay, formula of the probability. Formula of the probability. What is the formula of the probability, children? Children here. Number of favorable outcomes by total number of outcomes. Here 6 probability. 6 is favorable, 8 is total. 8 is total. So the probability is 6 by 8 means 3 by 4. She lost the game. 3 by 4. The chances is there. 3 by 4 chances. She lost the game. So 2 3 ja, 2 4 ja. So 3 by 4 is the probability. Now you see another one, children. Okay, here another special problem is there. A jar contains 24 marbles. Some are green and some other blue. If a marble is drawn at random from the jar, the probability that it is green is 2 by 3. Find the number of blue marbles in the jar. In every problem, we may find out probability. Or probability is given. The probability of green is given. We find out the number. So this is see children is a different type of the problem. So here, so total number of marbles in the jar. How many children? 24. We know that already given. Total number of outcomes. In the jar, some were blue, some were green. Let the number of green marbles. Let the number of green marbles. How many? We may take it as X. And then the number of blue marbles. Blue marbles, how many? 24 minus. Total 24. These are X. 24 minus X. Okay. Total 24 is there. Green marbles X. We subtract 24 minus X. Okay. That's it. Blue marble 24 minus X. Already the probability is given. The probability of drawing green marble. Already in the problem, the probability is given. What is the probability? So here, probability is equal number of favorable outcomes by total number of outcomes. This is the probability of drawing green marbles. We find the probability of green marbles. So favorable, how many green? X. Total 24. Now P of green and probability of green is x by 24. X by 24. Now, by the problem already given, probability has given in the problem directly. That's why here we find probability, given probability are equal. X by 24 is equal to 2 by 3. X by 24 equal to 2 by 2 by 3 already given in the problem. So we find here x by 24. So those are all equal. So x by 24 equal to 2 by 3. Now implies so we may take x 3x is equal to 24 into 2 by simplification method. So here x is equal to 24 into 2 by 3. We take this side. 3. So here simplify 3 1 ja 3 8 ja 3 8 ja. So 8 into 2. How many? X is equal to how many here? 16. X is equal to how many children? 16. So 16 are what are green marbles? Number of green marbles are 16. Number of green marbles 16. Now we find blue marbles 24 minus 16. Then the number of blue marbles 24 minus 16 8 like this. If probability is given, we may find number and favorable given probability. So this is a different type of problem. So see children, in these all are these type of questions he asked in different ways. He asked in different ways. We may ready to solve easily. So children, this is our fifth day end of the class. So children, you may practice well. Then only you gain much of knowledge on this. So children, once again, I will repeat some important concepts already which are learned. The first one is experimental and theoretical probability. And also we may discuss probability definition, and also in the chapter sure event and impossible event, and the probability lies between 0 and 1, 0 less than or equal to P of E less than or equal to 1. And also in this we may discuss like a random experiment and mutual exclusive events, complementary events like this. So these all are you may practice. Children, you may go through these concepts. You have must practice. Then only you have much knowledge on this probability. See children, the probability topic is very easy. Very easy. Please do practice well. Then you may get full score and annual examination. So all the best children. Thank you very much. Sir, hello. Sir, hello. Thank you children. Sir, please stop.